Hi, this is Dr. Frederick. So this is Module 1, Problem 2. And so what we have here is an Anova table. And we can click the icon here to view our data. And what we're going to notice is we have the table here, and then we're going to have 4 comparisons, or 4 groups that we're looking at. Now, what you should do for your work, if you're not sure what to do, just view an example here. So here's the example, and it's going to be a similar problem. And I don't think I can make this, well, I guess I can make it a little bit bigger. There we go. Okay, so now we have an Anova table, and it tells us how to think about our groups here. So C is the number of groups that we have, and N is the number of students that we have. So then we see that we have 4 groups. It's going to be 3 here. 124 minus 4 is 120, and 124 minus 1 is 123. They should add up. We use the degrees of freedom in conjunction with the sums and squares to get our mean square. So we're just going to divide here. That's what we would do in the problem, but let's work this problem here. Okay, so here they're just showing us what to do, and eventually going to get down to this table with 3, 120, and 123 for our degrees of freedom. Now, our mean squares are the sums of squares divided by the degrees of freedom. So 3 into 4389 is 1463, 120. So you don't need Excel to do this. You just calculate, do it in your head, really. And then what's the F ratio? The F ratio is the mean squared among divided by the mean squared within. That's 11. And so they want to figure out if that's significant or not. Now I'm just going to pull in this calculator that I got just by typing in F calculator. Okay, so here is one. It says, okay, degrees of freedom 1 is 3, the next one is 120. We want to know our alpha level is probably, I think it's, let's go back to what it was. I forget what our alpha level is going to be, but so we'll just calculate here. At 0.05 gives us 2.68 is the critical F value. If we do it at 1, it'd be much larger, okay? To have more confidence at 0.01, you're going to need a much larger F, critical, so 3.95. Okay, so when they say use technology, all it means is Google yourself a F calculator, and it will do that sort of stuff for you. Okay, so here's our table. Let's continue. What do they want us to? Okay, 0.01. At the 0.01 level, does F critical exceed, does our F calculated exceed our critical F? And what did they say the critical F was? Let's just look. They say 3.95. So they're doing the 1% alpha equals 0.01. So the F critical is 3.95, and the question is, are F larger than this? In other words, 99% of the time, if the null hypothesis is true and all the means are equal, you'll find F values from 0 to or 1 to 3.95. Okay, it's very unusual when the null hypothesis is true to have an F value greater than 3.95. And if we want our confidence to be lower, we saw that that the F value was 2 point something, a much smaller value. So 95% of the time, the value is 1 to 2 point whatever that value was. So we're going to reject the null hypothesis, and only when we reject this null hypothesis here are we going to ask if the means are equal or not. Or I'm sorry, we're going to try to figure out which one of these is not equal to the other. Okay? So so you reject the null hypothesis. It doesn't tell you anything at all about the status of equivalence for the mean. So this could be true. Mean 1 could equal mean 2 equals mean 3, and mean 4 be the one that is not equal. You just have to have one violation. If mean 1 is not equal to mean 4, then the null hypothesis is not true. So our job now is to say which means or which groups are not equal on their means. Now, what we have to do is to adjust our alpha comparison level, because we have many tests and we want our overall alpha to be 0.01 or 0.05, whatever the problem tells us. And that means that we have to do some tricky stuff. And the first thing I just showed is to use this studentized Q value. And so we reject the null hypothesis. Okay, now we're going to start comparing our means with the Tukey-Kramer procedure. And we're just going to compare mean 1 to another mean. Okay, now to figure out what our critical value is, we have to first ask ourselves, how many comparisons are we going to use? The more comparisons, the more difficult it is to find differences, because our critical values are going to be so high. So here we have 4 times 3 divided by 2 gives us the number of pairwise comparisons, and you can see that mean 1 versus mean 2 versus mean 3 versus mean 4. That's 3 comparisons. Now we have mean 2 versus mean 3 versus mean 4. That's 2 comparisons. And then finally mean 3 times versus mean 4 would be the 6th comparison. We're going to have 6 comparisons. And so then the next thing we do is just figure out the absolute differences between our 6 comparisons. And we'll just line those up. Now, we're going to figure out Q alpha, and we're going to multiply it by this value somehow. And I think all the n's are equal, so it doesn't really matter. Just figure out what the n is. But let's figure out how we do this. Well, you get that from another table, and see, I just Googled studentized range. You probably find a calculator, but here's a table. I never look at the book for tables, and it's right on the internet. So here we have 4 treatments and 120 or more subjects, and then they're stacked. So the top value is alpha equals 0.05, and the bottom value is alpha equals 0.01. So we find our Q value is 4.5 here. Okay, so see, there it is. Q is 4.5. Then you're just going to do what? What are we doing? We're getting a critical range, okay, and we're going to say what is the critical value to say that a difference is that a comparison is actually different. Okay, so it's going to do your 6 comparisons and get your 6 different values. And I guess they have one of the groups doesn't have an equal n, so you're going to get 2 different values here. One is 11.06, one is 9.19. And you're just going to just work out a little table here. We found the difference here, and this does not exceed the critical range, so that's not different. That's not different. This is different. 16.58 is greater than 9.19. That's not different. This is different. Okay, so we have 2 differences here. So look, when you run into a problem, this is what you should be doing, is just working your way through. It shows you how to do everything. Shows you how to do everything, and then your question is, can you apply the method here to the data that you possess? Now let's just look at something real quick. This isn't a good example, but most of these cases, what you're going to do is you're just going to copy your data right out of the problem and then put it in Excel. And then if you want to use pH stat, some people are going to use StatCrunch. What? Fine. What I want to tell you is, if you look on YouTube, you're going to find many examples of how to use pH stat, many examples of how to use StatCrunch. And if you can't find what you need, just ask me, and I'll make a little video like this. I'm happy to do it. Okay, thanks very much.